Use a general form of coterminal angles to find the specified angle. In part A, we have a principal angle of 300 degrees and we want to find the coterminal angle after 3 rotations counterclockwise. Recall that the general form of coterminal angles is theta c equals theta I plus or minus n times 360 degrees, if we're using degrees, or theta c equals theta I plus or minus n times 2 pi if we're using radians. The initial angle is 300 degrees and there are 3 rotations counterclockwise. We want to add, since the angle is becoming more positive. The coterminal angle after 3 rotations counterclockwise is 1380 degrees. In part B, we have a principal angle of 2 pi over 5, and we want to find the coterminal angle after 14 rotations clockwise. Start with the general form of coterminal angles for radians, theta c equals theta I plus or minus n times 2 pi. The initial angle is 2 pi over 5, and there are 14 rotations clockwise. We want to subtract since the angle is becoming more negative. Simplify the expression. Get a common denominator of 5. Subtract to get negative 138 pi over 5. This is the coterminal angle after 14 rotations clockwise. In part C, how many rotations are required to find the principal angle of negative 4300 degrees? State the principal angle. We have an initial angle of negative 4300 degrees and we want to rotate the terminal arm counterclockwise until we have a positive angle. Set the equation equal to 0 and solve for n. This will tell us how many revolutions are required to get an angle of 0. Isolate the term with n on the left side of the equation. Divide both sides by 360 degrees. This gives us n equals 11.94. It takes 11.94 counterclockwise revolutions to get to 0. Keep going to 12 full revolutions to return the terminal arm to its original position. The principal angle is negative 4300 degrees plus 12 times 360 degrees, which is equal to 20 degrees. In part D, how many rotations are required to find the principal angle of 32 pi over 3? State the principal angle. We have an initial angle of 32 pi over 3, and we want to rotate the terminal arm clockwise as many times as possible without getting a negative angle. Set the equation equal to 0 and solve for n. This will tell us how many revolutions are required to get an angle of 0. Isolate the term with n on the right side of the equation. Multiply both sides of the equation by 3 to eliminate the fraction. Divide both sides of the equation by 6 pi to isolate n. This gives us n equals 5.33. It takes 5.33 clockwise revolutions to get to 0. Backtrack to 5 revolutions to return the terminal arm to its original position. Now find the principal angle using 32 pi over 3 minus n times 2 pi. Start with the original angle and subtract 2 pi n times to get the principal angle. Rewrite the expression and plug in 5 revolutions for n. We need to unwind the terminal arm by 5 full revolutions to get the principal angle. Simplify the expression. Get a common denominator of 3. Subtract to get 2 pi over 3. This is the principal angle as an exact value radian.